Alright, so this is going to be my first unit in geometry, or not geometry, Algebra 3, Sequence Assessment Recovery. So this is the recovery that you have to do and turn in before I give you the recovery exam, the recovery quiz. So you got to go through and actually have all this. So right here it says you may use a calculator. So everyone does have a calculator. I'm going to show you guys on the calculator here in a minute. Write a formula that defines the sequence, this. So if I'm looking at my numbers, my first number is 3. Next one is 5. Next one is then. All right, very good. So now, what's happening in between each of those? Adding 2, right? What's going on? So we're adding 2 every time. So this is not going to be a recursive. So I'm not going to require the previous term. I want just a definition for the sequence. Not recursive though. So for this one right here, I'm going to go with these. So if I'm adding 2 every time, so if I'm adding 2, remember that's plus 2, plus 2, plus 2, plus 2. Now, repeated addition is the same as multiplication, right? Repeated addition is the same as multiplication. So, we always do this way. In these terms, I start off with my first. My first term here is 3, right? Okay. Starting with 3 plus, so I'm adding, how much am I adding? I'm adding 2, right? I'm adding 2. But now, if it is repeated over and over again, what am I have to add to that? N. I have to add an N, so it's 2N. So you'll see in a second equals my f of n. Now we're going to define it because it's multiplying, right? It's repeating the addition of 2, right? Since I'm repeating 2, 2, 2, 2, 2 every time, right? I keep repeating that, it's going to be like this. Now I'm going to show you guys for my values. I'm going to do this. Let's define n. Going to be greater than equal to 1. Let's see. So in my calculator, Fadi, shh. So it's going to be 3 times 2 times, oh, I'm sorry, 3 plus, sorry. Plus 2 times, now, what do we say for n? Let's try 1. Is that my first term? Is it? It's my first term has to be what? 3. My first term is 3. So is 1 the right term? Say no. No. So let's try it again. Let's try it with n being 0. So I'm going to do that. So let's try 0. Does that give me my first term? It does give me the first term. So I'm going to say that n has to be greater than equal to 0. So if I keep doing that, that's where I'm going to get my values because this is not a recursive sequence. So the recursive one, I would actually have the first one given to me, then there would be an f of n minus 1 in this. But this is not recursive. Alright, so now on this next one right here, this one was a big issue for most people on the first quiz. This was a big issue. Now, I'm going to expand my table here just to help you guys out. I'm going to expand it. So I'm going to go this way because, you know what? It works out for me a little bit better. So I have my n. Ah, crap, that's a horrible one. Wow, I cannot draw a straight line. It's so humid in here, like my hand's sticking to the paper. I don't even know where my ruler went. All right. So So hopefully I'm not going to need that much. So it's going to be n and then g of n. Oh, that's horrible. I can't go with that. I can't do it. I can't do it. There we go. That's better. There. All right. Forget all that. So n g of n. Very good. So my first term, 1, right? Say yes. 1. What comes after 1? 2. What comes after 2? Uh-oh. What's supposed to come after 2? 3. And then after that? 4, then 5. All right, so let's see how this lines up. So if we're looking to see how this lines up, 1 is with 3. 2 is with 3 is with, I don't know. But 4 is with 24. Now, this is either going to be arithmetic or geometric. Let's start by checking to see if it's going to be arithmetic. If it is arithmetic, I am doing what? Very good. Adding, subtracting the same number. All right, let's see. Since there is missing term here, that's what I have to look for. So if the missing term, so it goes 3 to 10, what am I doing? Let's see. So I'm going to go plus 7 here. So let's try it again. So let's go plus 7. So 10 plus 7 is? 17. And if I go plus 7 again, that gives me? That does give me 24, doesn't it? So since it does give me what I need, this piece right here is 17. And then if I do plus 7 again, it's going to give me, I don't know, what's that, 31? Yeah. So by filling in the missing right here, it helps out a lot to tell you what piece it's going to be. So now, I know this is going to be arithmetic, and it's going to be adding 7 every time. So let's go ahead, and I'm going to write a recursive definition. So, now, class.
Yes.
Okay, good, all you people. All right, so recursive definition means what? The previous term. So if I'm using previous term, what notation is necessary? N minus 1. So I'm going to have the n minus 1. So I'm going to start off with f. Actually, no, this is g. Dang it. G of n is equal to g of n minus 1. And what am I doing to that? Plus 7. Very good. Now let's define our n's. In a recursive, which one has to be given to you? The first one. The first one's given to you, right? So if the first one is given to you in recursive, that means that you are going to find which ones? The next one, which would be? 2. Because in this one here, in a recursive, the first is given to you, right? The first is given to you. That's always in the recursive. So this is my first one. So n here is 1. So that means for this, we figure out everything from 2 on. Now, since I have this, right? And in recursive, what do I also need? What is the first term? It's going to be 1. So I'm going to say g of 1 is equal to 3. So all of that is my answer for this one. All of that is the answer for that one there. I have to define n. I need to show my recursive of the n minus 1. And I have to state my initial term. Because if I have something that says previous term, I have to know where I start from. And that's necessary for this. Okay. Did I confuse anyone yet? Not too bad. All right, so, dang it. You know what? Don't record this thingy. There you go. Now, next one, it says first 2 numbers in a sequence of h are 1 and 5. If h is arithmetic, so arithmetic is doing what? Very good. Adding, subtracting. So if we have adding, subtracting, what am I going to do from here to here? Plus 4. So I'm just going to put a plus 4 right here. So write a definition. Does it say recursive? No. So this one's not going to be recursive, so I'm not going to need the n minus 1. So I'm going to state whatever it is. So I'm going to say that h of n is equal to, now, if I'm adding every single time, repeated addition is the same as multiplication. So what's my initial term? It's 1, right? So I'm going to say 1 plus 4 times n. Very good, times n. Did that make sense or no? Did I confuse you? This is your recovery, so if you guys don't know what you're talking about here, now's the time you guys really have to know. Test is tomorrow. Yes. Fatima. No? Okay. What?
So when it's the sequence, it's always times n?
Yes, it's going to be times n. And if it's a, like the next one is geometric. So that's going to be a multiplication. So repeated multiplication is going to be the power. Okay, and that's the exponent. That's what we're doing on the next one here. So very good. So now let's define n. So n is going to be greater than or equal to. Is it 1 or 0? I hear 0 and 1. Let's take a look at the calculator. So let's figure it out by using the calculator. So it says 1 plus 4. 1 plus 4 times, let's say it's 1. If it's 1, if n is 1, that's 5. Is that my first number? No, it is not my first number. So let's go back up. So let's delete that one and try it as a 0. There you go. It's got to be 1. So n has to be 0 for this to be 1. Okay, that's my first number. All right, let's take a look at the next one now. So next one says, dang it, stupid thing, get off there. All right, next one says geometric. So same thing, but it's a geometric series. So if I'm going from 1 to 5, what is it doing? Multiply by what?
5.
So times 5, right? So if it's going to be times 5, so it's a repeated multiplication of 5. So over and over and over and over again. So what is my initial number? The initial number is what? 1. Initial. That means you're starting. Initial is your starting. So I'm going to say h of n is equal to
1.
times
5.
5. 5n? N power, right? To the n. Very good. So now we have to define n's. So you could use your calculator if you need to define the n. So n greater than or equal to. So my first number in the sequence is 1, right? First number is 1. So let's take a look at what my calculator says. So 1 times 5 to the, what do we want to say? 0? 0 or 1? One of them. You want to try 1? Okay, let's try 1. Is my first number 5?
No.
Nope. The first number is supposed to be 1, right? So let's try it again as a 0. There we go. So n has to be greater than or equal to 0. Alrighty, let's take a look at the other side now. It says a piece of paper has an area of 64 centimeters squared. Strips of it are cut off that is half the original area. From that strip, another strip is cut off that is half the area of the first. Okay, so watch this. Draw my nice little paper right here. So what am I doing to the area each time? Dividing by 2 or multiplying by a half, right? Okay, that's good. So here's the sequence right here, representing K, where K of n is the area in square centimeters of the strips of paper and n cuts. All right, sequence K geometric or arithmetic? Is it geometric or arithmetic? Geometric. Why is it geometric? Dividing by 2, right? Say it's so it is going to be geometric because it's dividing by 2 every time. So you say that. Now, the next one says write an equation to define the sequence K recursively. All right, so if it's recursively, like I said, what do we know about recursively? I need the previous term, right? So let's go ahead and state the first term. So if I'm stating the first term, I would say that, what's my first term? I would say K of, say it. What is my first n that I use? 0. Look right here. It's K of 0, right? That's the first one, right? K of 0 is 64. That's what I'm looking for there. So K of 0 is 64. There we go. So from there, we have the first term. Now let's define it. So since I'm multiplying by a half every time, I'm going to say K of n is equal to somebody. Not divided by 2, not yet. N minus, there we go. I have to have previous term. Remember, it's recursive. So I have to state that it's going to be K of n minus 1, which says my previous term. And what am I doing to that previous term? Divided by 2. I'm just going to write multiply by 1/2 because it means the same thing. Very good. And now, since I have initial, I have my definition, and now define the ends. What ends? This is the part that a lot of people get wrong because it's different than the other one. In recursive, they give you the first one, and you have to find which ones. Ones after that. So which one's after that? The ends. Yep. It'd be 1. Because you're given the first, which is here. You're given the first here. You have to find the ones after that. In a recursive, you have to have the given first value, initial value, and then you find the ones after that. So that's only with recursive. If it was the non-recursive, okay, the explicit, that's the ones where you're plugging in n to get that number, to get that term in the sequence. All right, so now this is the problem that a lot of people had on the previous test here. For term K of A, what are some values of A that make sense? What are some values of A that do not make sense? Explain your reasoning. People on a plane, right? What values are we going to use? We're going to use positive, right? Okay, so we're going to use positive. Anything else we're going to use? Whole numbers, right? So I would start at where? I could start at 0, right? Because we made 0 cuts here, didn't we? So I would start at 0. So I'd say, okay, 0. 0 to what? So n would be greater than equal to 0. Very good. Now what types of numbers? Whole numbers, right? Or integers, right? So I would say positive integers. Okay, so there's part of it. What are some values of a that do not make sense? Negative, right? So we're not going to have any negative cuts. Yeah? Okay, so we're not going to have any negative cuts, are we? No, remember, I kept saying this as people on a plane. Any of those negative people on a plane, they get thrown off, right? Okay, so no negatives. No negatives. Anything else? No decimals, right? Because a person's a person no matter how small. They're always people, right? So we're talking about people on a plane. We're not going to have decimals. So no decimals or no fractions. Now, does anyone have questions over those statements right there? Like I said, this is on the test. This was on the previous test also. And a lot of people didn't understand this right here. So we're talking about right here, whenever we're doing this right here, things that are going to make sense. You're not going to have a negative cut. You're not going to have half a cut, are you? No, you're not going to make half a cut of this. Yes? Okay, good. All right. Don't forget, like, share, and subscribe. There's PayPal option or Bitcoin. Yeah.